Hi, everybody. I'm Benoit Maujean, CTO of Mikros Image. And I'm going to talk to you about our experience of running and rendering a feature film animation called Sherlock Gnomes with the help of AWS. So what's the agenda? I'm going to give you a little background with who we are at Mikros, what is the positioning of Mikros Animation, where do we start with this feature film, Sherlock Gnomes, and then we're going to get deeper in the motivations and the outcomes of cloud rendering with us, and some conclusions on the learned lessons and the perspectives. So Mikros, we are part of the Technicolor group. In fact, we are positioned across 3 different business lines. The advertisement under the branding name Mikros MPC Advertising, the VFX and DI under the branding name Mikros Technicolor, and the animation for feature films and a bit of episodics too now at the moment under the branding name Mikros Animation. We are mainly located in Paris with our main premises, but we are also located in Belgium, in Liège and in Brussels. We're located here in Canada in Montreal. We are also located in London, and we have also the support of MPC team and Technicolor team in Bangalore. Okay, to give you a quick overview of what we are doing on these 3 business lines, this is our demo reel.
In the night, most of the time we shut the light. In the night, most of the time with the shadow in your light, we move in the dark, we attack as a pack, them style you in the back,
Thank you. Okay, to give you more background about Mikros Animation. In fact, it all started, the animation. We were a big company in visual effects business before for commercials and feature film. But it all started in 2009 with a short film called Logorama. It was directed by a bunch of directors from an agency called H5 that were famous in commercials for TV. Has anybody seen Logorama in the room, by the way? Because if you haven't seen it, it's a short feature film. It's really fun. And it was pretty well. We've been working on that for 1 year and a half. And we got awarded with an Oscar for the short feature film in 2010. And then the big, huge step was with Asterix, because it's a famous license in France. And that was the first time there was a feature film in full CG with Asterix. So we had the experience of big infrastructure with big VFX, but we had to build up a pipeline for animation. And with all the demanding of, on the one side, the production company called M6, and of the creator of Asterix Uderzo. Anyway, so it turned out pretty well. And then we've been doing some partnership, in fact, with Onyx Film in Montreal. And with them, we complete a couple of production, Mune and the César winner, The Little Prince in 2015. And then we produced Sahara, still with in Montreal in 2016 for La Station Animation, Mandarin Production. And then the other big move was Captain Underpants for DreamWorks in 2017. Sergeant Stubby, which was more for an independent company, Fun Academy in the States in April 2018. And we are still, at the moment, producing the Asterix #2, the Secret of the Magic Potion, expected to be released in December this year. Beginning of 2025, following Asterix's success, Paramount asked Mikros to produce a few tests for some of their upcoming projects. And one of them was the sequel of of Gnomeo and Juliet, called Sherlock Gnomes, sorry. And it was green light in the studio, but they were looking for a production partner. So we did some tests at the end of the year with 10 artists. And this test was a success. And this test, in fact, enabled us to get in touch and to understand the creative needs with the director, John Stevenson, and all the creative people from Paramount. Well, because I like the pictures, I'm going to show you the trailer if you haven't seen it. It's pretty sounded. Anyway.
Romeo and Juliet are moving to a whole new garden.
All clear!
It's not quite perfect, but it's ours.
Think of all the adventures we're gonna have. Look, there's a pool! Woohoo!
I'm okay. Excuse me.
Oh, Mankini, that is just... Are you done?
I've made a jacuzzi.
Humans coming!
Poses, everyone.
They were supposed to live happily ever after. But when their world is in danger,
Juliet, the gnomes, they're all gone.
there's only one gnome to call.
What the fertilizer?
I'm Sherlock Gnomes, sworn protector of garden gnomes.
You mean, except for the one you literally just broke?
Broken? Who's broken? Oh my God!
This March,
All ahead, full, Watson! Those gnomes are in terrible danger.
from the director of Kung Fu Panda,
We can't let anyone hear this, but they're going to smash us all tomorrow night.
Smashed? This guy said we're all going to be smashed tomorrow.
prepare for an adventure.
We have to get across that river. We'll need a ship.
No ship, Sherlock.
Into the great unknown.
Benny, our next clue is in the park. Give us directions quickly.
Just follow the blue line on the ground until you find the giant red thumbtack. Careful, it looks pointy.
James McAvoy, Emily Blunt, Chiwetel Ejiofor, Mary J. Blige, and Johnny Depp with original music by Elton John and Bernie Taupin.
We have to go undercover. Let's go. 2 forward. Hold.
Ooh.
I said hold.
Forgive me, I've never been the back end of a squirrel before.
We've been spotted.
Sherlock Gnomes.
That's not how a squirrel shakes its behind. Mankini, can you demonstrate? You see what I'm doing? See? Do you see?
Yes, you're acting like a rear end.
As all the creative team of this production was in London, they were set in London. It was part of the deal with Paramount to set up, to open, in fact, for us a shop, an animation shop in London, close to them. And then we started a 20-month production. To give you some figures, we finished up with 290 artists that worked on the film at the time, and across both studios, so in London and in Paris. So what were the challenges of this feature? Well, one of them was, of course, to launch a brand new studio in UK, to do the recruitment, to set up the infrastructure. To be honest, we had great help from our big brother MPC, because they was just finishing Jungle Book and they have some free space, so that was happy for us. And also there was some very specific stuff at the beginning. The director, John Stevenson, was very clear that he will continuously keep up changing and updating the storyline all along the production timeline. So that was something very impressive. We have also some creative challenges, like filming some small characters in a big environment, so this is more creative, but this is a lot of power regarding the creative aspects. And anyway, so with all these challenges, from the beginning, we knew that we were about to render, re-render, re-render again because of all these constraints. I still have to conclude with this conclusion, this introduction, and to give you a look. There's this sequence I like, which is one of the most impressive regarding the creation, and then you can figure out
what on earth
what we have to do to shoot this Gnomes Garden in London urban environment.
Getting smashed for some flour?
Not some flour, our flour. I did this for you.
You did this for me? For me? I've got responsibilities. I don't have time for this.
No, you just don't have time for us.
There will be plenty of time for us after I get the garden ready.
Unbelievable! What do you care more about, the garden or me?
Oh, you're being ridiculous.
That is not an answer.
The garden can't wait, and you can.
Nomeo, help! There's something here! It's a...
Benny! What's going on?
Okay. So talking about the rendering, so why do we need this power? I was referencing when we were talking about challenge. The render pipeline at Mikros is based upon these components on the left-hand side. So we have Katana and Arnold for the render. For the dispatching, we have Tractor. For the fur and hair, we have Yeti. And for the management, we use Shotgun Toolkit. And we have, of course, a couple of proprietary tools to monitoring the farm. Here you have some global stats which give you some figures around the rendering needs. It's not only for animation here, so we have a couple of hours of calculation per day in average, with a couple of hundred of calculation jobs. We move around 1 to 10 terabytes of calculated data, and maybe most impressive is some of you know that, but for VFX, the average time is, let's say, for an image is 1 hour with a 20 iteration. This is average, so I give you some idea. For advertising, this is even more, and the peak is for animation because this is the biggest resolution, and we have also to do the right eye and the left eye for stereo as well. So taking this into account, how do we do it normally? Well, like everybody, we have a render farm inside, so if you have a couple of years, not far from 1,000 Unity of render farms. And of course, we use the workstation when they are idle, especially by night. And the key point also is the human factor, the wrangling. So we have 3 wranglers, one in Paris, one in London, and one in Montreal to try to play around with the clock monitoring. And we have also additional support when it's possible in Bangalore. So this is the classic way of doing it. But of course, when I mentioned the challenge needs, from the beginning of this production, we said we have to look what we are able to do in the cloud. So, what were our objectives regarding the technical challenge I mentioned before? So one of them is we wanted to have the same customized instance in the cloud with the same application, of course, because we don't want to change our pipeline. The security is a big notion regarding big studios like Paramount. Of course, this has to be on demand because we don't have. This is the as you know this is the key element of rendering in the cloud. It's to have it on demand. As Chris explained, if you've seen the previous presentation, we have to deal with our render management Tractor transparently, and of course with competitive pricing. What you can see is that for security reason, the storage has to be kept inside our premise because we were not allowed to store production media in the cloud. So in fact, we needed to mount the internal storage from the machine in the cloud through a VPN tunnel and with a dedicated point-to-point access provided. The access to and from the remote computer zone was only permitted for Mikros, of course, limited to Mikros production network. And to facilitate the throughput of the storage, We set up remote cache with Avere. I guess some of you knows about the Avere caching. It's SSD storage appliance with that enables to have read-only data without storing them permanently. What you can see here also is we have our internal infrastructure, which is inside, like the licensing manager, the control of the access, and we also have in the production zone, so in a protected area, we have our on-premise compute farm also. So about security. First of all, we have to have the approval of our customer, of Paramount, with this architecture. And to do that, this technical implementation was validated by a third-party independent company. We also have to comply with the MPAA recommendation, which is something very famous for the studio, which is like the standard you have to follow if you want to set up this kind of production. And as I said before, there was no access from internet to at any point with the remote computer zone on the local production zone. Okay. So what was the way to set it up? The on-premise config is the following. We have a render farm with 10 physical cores with that is basically every render farm is 40 nodes with 64 or 128 gigabytes of memory. So this is our target we had to cope with in the AWS infrastructure. So what was Mikros' choice? In fact, Mikros chose a mix of various on-demand spot instance, not on-demand, spot instance in AWS. That means the workstations that are available, but with an interesting price, up to 80% of the regular price. So, and as you see, we chose a mix of instance depending on their availability. And it fits pretty well with our need to cope with the burst of rendering we had for this production. We have a couple of on-demand instances, but again, the economic model was to pick up this, what they call spot instance. For those who are at the previous presentation, Chris explained the difference, the financial impact. Okay, regarding the management of this remote computing, we had to set up some stuff like, in fact, we didn't push all the jobs into the cloud. We pushed the jobs that were CPU intensive, but with a small I/O, so no comps because of this internal storage. We didn't want to have too many throughput with the compute storage, so intensive CPU and limited I/O. And also, of course, we had to develop some dedicated tools. And one of them was to assign the jobs that could be pushed into the remote computing. And we can add instances on the remote compute with the AWS API. And one of the important stuff is to stop the idle instances, of course, to get rid of the consumption of it. We also have to develop some monitoring tools. Some of them were already there, but we adapt them for this purpose. So we have data analytics based upon the logs of a tractor to see to know about the completed jobs, and also we have to have an estimation of what were the remaining tasks. That was basically stored in Google Sheet. Okay, some graphs now. Here on the y-axis, you have the number of nodes, and these nodes concerns all the compute resources. So the dark color is the idle stuff. The light color is the running stuff. So on green, you have the Mikros on-premise workstations. On purple, you have the render farm. And on dark and, on yellow, you have the AWS structure. So this is around 3 days. What we see is at the beginning, we were not that good because you can see that the dark yellow that is the idle instances at Amazon, we didn't kill them rapidly. So we learned to do that because, of course, we don't want to pay for something which is not running. So you can see it's progressively and shot. And, well, there's not much to say about. You can see that we prefer, in fact, to run our jobs on the the remote farm, sorry, because we had some problem management with the file system anyway. And the other thing that you can see is this is Saturdays, Sunday and Monday, and then the team is back on Monday, and we have to relaunch the stuff, first with our local stuff, and then again with the remote compute. What is interesting also is that you notice that the maximum is 5,000 nodes, so up to 200K cores. Another way to see that here, the axis is the hours, so you can see we have a peak. So this is on a larger scale, not even, but you can see that the maximum, the peak is 130,000 hours dispatched on these 4,000 or 5,000 nodes. And here, in fact, you can see what we have been doing regarding the fact that we need to render the feature film for the left eye and the right eye for stereo needs. So this peak of 130,000 hours happened in, you can see as nearly 1 day, 1.5 days. So this is something which is pretty impressive, and that we couldn't do only with our own premise. This one maybe is the most interesting because here you have in a y-axis you have the hours of rendering day as well. So here in light yellow we have, in fact here you can see that we have 2 instances of AWS render farm. So why is that? We started rendering, in fact, with the Frankfurt data center, which is a smaller AWS place, but with a good latency requirement regarding the project. And then we were able to spill over another bigger AWS instance in Dublin, the dark yellow. And you can see, in fact, at the end of the project, we were, in fact, running over 3 different compute resources. In purple, the on-premise resources. So the one in Dublin, and seamlessly the one in Frankfurt and the one in Dublin. So what is interesting here also is to see the ratio between the on-premise render farm. If you see at the peak, which is, again, 114,000 hours, I mean, this is up to 15 times of the local render. So this is something crazy. In fact, this is not the original plan, to be honest. At the beginning, we figured out that we were about to, let's say, double the capacity. And I forgot to say, to mention that this is, let me check, this is a 5 months statistics, so that's interesting. And what you see is that during the 2 or the 3 last months, in fact, nearly 90% of the production was rendered into AWS. And of course, as you know, the end of the production is probably the time when you have to render the final shots with the final quality, and this is where you need the more power. That explains why. So, okay, a few figures. So, well, I'm not going to read all of them, but one is interesting is the nearly 7 million calculation of hours. 700 terabytes of data. This is not for the cloud, but this is to explain that we had a lot of throughput. And yeah, I said more than 4,500. In fact, the real figure is 170K cores over 3 different data centers. So you can read by yourself the figures, but this is, we were impressed ourselves by this figure. We never have imagined that this production was about to go there. This is a quotation of the director of the animation studio at Mikros, and basically the first instance is the most interesting. Like, cloud changes what's possible because we can adjust our capacity to allow for more creative iteration. Remember, the director said, I want to be able to change or to tweak the storyline at every time of the process. So, and that's why, in fact, most of the computing stuff happens to be in AWS. Okay, so what is the lessons we've learned through this first attempt? Because yes, I didn't mention that, but that was our first experiment in the cloud rendering. And also I didn't mention that this was possible with the collaboration between Mikros Image, Technicolor, and AWS teams, because it's not easy to stage all your resources and to adapt to that, the spillover between the two Amazon Web Services. I mean, that was something pretty interesting for us. So one of the lessons is that every component of your infrastructure is put at work and it needs to move to a higher scale. Not only the computing, but every component. So the license management, regarding this case, we were dealing with our own licenses. And in fact, the difficulty here is that this is not the same granularity, because regarding the computing, you can, let's say, crack it up and be built by minutes, sometimes by seconds. Regarding the licensing here, we are still by the years, so we are trying to figure out a different strategy with the different software editors, but it's not that easy because it's a kind of new philosophy, and it's not easy to switch your licensing from one workstation to another one, maybe over several territories. So this is a tricky business deal. Regarding the infrastructure, the infrastructure, I mean, the storage, the network, even the the LDAP, the DNS, everything was cracked up, I mean, massively, and sometimes that were really difficult. The log, I mean, the log server, you have to deal with your logs very carefully because it can break up massively. The disk space I've already mentioned, and so for the scale, the good stuff was the Avere caching. So because so we finished us with 10 nodes of Avere to fit with the data throughput. To be honest, we experimented some difficulties with Avere because they were sometimes hanging. So we have to monitor the Avere. It gets better at the end because we were better, and I guess they were better too on their side. But this is something you absolutely need to do the throughput required by this kind of infrastructure. So what's next? Obviously, we have to improve our management tools, our render management tools. One of the idea we have is we try to figure out to define a kind of standard image to benchmark all the renders, because you understood that we have, in fact, a great variety of render nodes regarding our on-premise, regarding the different instances of Amazon. So a good idea for us would be to have this kind of standard image, to have a kind of global metric, because you cannot talk about the CPU, that's too easy, that's a figure which is too easy to figure out. So a standard image would be something which would be interesting. It's a bit like if you are talking about the speed or the distance you can do with a car. I mean, it's not the same way. We have to improve the match. Remember you said we didn't push all the jobs into the cloud. So we have to be maybe more specific about the complexity of the jobs. And as the guy from FuseFX said, maybe there would be some stuff to study regarding some statistics about the type of jobs and the render time of these types of jobs you can do and learn from the previous day or the previous months with some machine learning, why not? We have to manage to be able to manage longer run jobs. And one of the strategies we don't have also at Mikros, and to have this checkpoint and recovery strategy, which of course relies on your render engine. But so the thing is to be able to continue a frame that has been interrupted for any reason, and to carry on this instance on Amazon. This is something. If not, you will have to re-render all, and obviously it will be a waste of resource and a waste of time. We also had some problem with our storage, so the decision is now to move to New Delhi's infrastructure, to give you the secret. And I mentioned that before. We hope we will be able to have a better compatibility between the licensing and the compute availability. I mean, different granularity is not easy to cope in a finance way. next also is that happening, because we are at SIGGRAPH, so I take the opportunity to say that. We are now starting SpongeBob in Montreal, and we are recruiting. And I guess this is the end of my presentation, and I'm ready for some questions. And again,